dimension. Okay, all of you write down construction of analytic function whose real or imaginary part is known. This is the topic. Suppose we consider the function f of z is equal to u plus I. U real part is u is no. So this is we want to construct it. If suppose we consider f of z is analytic function whose real part is no. If this real part, if you know, we want to find the imaginary part. That means we can find this. We can find this. So how can we find this? For this one, we have two methods. Method 1 and method. This method 1 is completely depending upon the previous knowledge of the ordinary differential. Then we know the exact differential equation. In your first year, the ordinary second semester, you have the ordinary differential equation. The exact differential equation. The same theory we use and we find the solutions for this analytic function whose real part is null. Okay, whose real part is null. Then we find the imaginary part. Okay. So here, what we consider first, we know that the total derivative of the function dv. What is the dv? The total derivative. So this is also in the partial derivatives. We have the total derivative by the definition of the total derivative. dv is equal to dou v by dx into dx. Here, what is v? V is a function of x and y. V is a function of x and y. U is also a function of x and y. If we know that v is a function of x and y, the total derivative of v is dou v by dx, the partial derivative with respect to x into dx plus dou v by dou y into dx. This is we consider. But in the complex variables, we have the analytic function for the CR equation. So what are the CR equations? But dou v by dou x, this is equal to minus dou v by minus dou u by dou y, and dou v by dou y is equal to dou u by dou y. This is the CR equation. So using these two equations, we will change this total derivative as this total derivative as dv is equal to dv is equal to, so dou v by dou x is equal to what? Minus dou v by x minus dou v by what? Y. This is I'm writing dou v by y into x plus dou v by dou y is equal to what? Dou v by dou y is dou v by that is dou v by x. Okay. This is answer. So dou v by dou x is I'm writing minus dou v by dou x because here what we want to find? We want to find v, the function v we want to find, imaginary part, using the real part. So therefore, the total derivative dv is equal to dou v by dou x into dx plus dou v by dou y into dy. But this u and v is coming from f of z. F of z is analytic function. Therefore, f of z is analytic function means what? It is satisfying this two axes. Therefore, we are taking dou v by dou x dou v by dou y and dou v by dou y equal to dou v by dou x. This is the two axes. Okay. So from this one, I am changing dou v by dou x and dou v by dou y as minus dou v by dou y and dou v by dou x. Okay. From this one, I want to find the v. Okay. So here, taking m is equal to minus dou v by dou y. This is our concept. And n is equal to dou v by dou y. This is the answer. This is the answer. So from this one, we get so dv is equal to what? This two substitute here m dx plus n. So now m dx plus n dy is equal to dv is equal to 0 is exact differentiation. Then dv is directly integrable. dv is integrable. From this integrable differentiation integration cancel, we will get the v value. So this is the way we'll find the v value. But when it is possible, only m dx plus n dy is exact differential equation. What is the m dx plus n dy is exact differential equation? We go for the definition of the exact differential equation. Dou m by dou y is equal to dou m by dou y. Then we call the function is m dx plus n dy. The equation is exact differential equation. Okay. So from this is I'm considering as equation. Now
Sir, once previous topic. Finish, sir.
now we consider dou m by dou y minus dou n by dou y. This is our answer. So what is dou m by dou y? You see that dou m by dou y means this is differentiating with respect to y partially. N is the differentiating with respect to y partially. So that is minus dou square u by dou y square. This is we are differentiating with what? The left hand side, right hand side also dou square u by dou y square u. So that is the answer. So dou minus dou square u by dou y square minus is there, this minus. What is dou n by dou x? Dou n by dou x means what? Dou square u by dou y square dou x square. This is the answer. N is equal to what? Dou u by dou. Therefore, again differentiating this one, I will get dou square v by dou. So this is equal to what? Minus del square u. Minus del square u. So what is minus del square u? Minus del square u I am writing is what? As u satisfies Laplace equation equation, we get del square u. This is del square u is equal to g. Laplace equation satisfying u means what? Del square u is g. Hence, del square u is equal to 0. Then this equation becomes 0. Dou m by dou y minus dou n by dou x is 0. This implies what? Dou m by dou y is equal to so, dou m by dou y is equal to dou m by dou x means what? The equation 1 is an exact differential equation. Exact differential and equation 1 can be integrable or integrated and we can be determined. So once you are getting u is what? Now u and v are known and the function f of z is equal to u plus iv is determined. This is the way we determine the imaginary part of v by using the part of u, real part of u. Okay. Can I move? Can I move forward? So the method 2 Thompson method. So what is the advantage of this method is here the function f of z we determine directly without finding the u or v, that real part or
Sir, once
imaginary
previous slide.
part. Yes.
Sir, once
Stefan?
previous slide button. Okay, sir. Thank you.
Okay. So this is the advantage of Miller's Thompson method. So here, without, if you know only the imaginary part or real part of the function, so by that one, just simply directly we are determining the function f of z, the analytic function f of z. Okay, that is the advantage of Miller's Thompson method. పెద్దగా వస్తుందా వాయిస్ పెద్దగా వస్తుందా ఓకే ఓకే అయితే హాయ్ చిన్న ఓకే సో ఫర్ దిస్ వన్ all of you write down. Let us suppose consider the function f of z is equal u of xy with I into v of xy. This is the given function. So we want to find the u and v both, either this one or this one. If u is given, then we find the v value, or v is given, we want to find v u value. Okay, but in Miller's Thompson method, if you have u or v anyone, so directly without finding the v or without finding u, if you have u, then without finding v, we find the function we are talking. How is it? You see here, since we know that z is equal to what? X plus and the conjugate of z is equal to x minus. So we have from this one x is equal to what? How you will write in terms of z? That is z plus z conjugate by 2. You see, this is the real part of x. Similarly, y is equal to what? Y is equal to z minus z conjugate by 2i. So you divide this one, then you will get this y. So this value I am substituting in the given function. F of z is given u of xy, u of x. X is this one, y is this one. So reverse substitution. Okay, instead of x, u is function of x1. So this is f of z. So this x and y we are writing in terms of z. This is the reverse substitution. Okay, so that means z plus z conjugate by 2, comma z minus z conjugate by 2. This is u of x plus I into v of z plus z conjugate by 2, comma z minus z conjugate by 2. Okay, this is what we can take as equation 1. This is equation 2. Now considering this relation as a formal identity in two independent variables z and z prime. Okay, for that one we are putting c z conjugate as equal to z. Into we get what we will get f of z is equal to, when z conjugate is equal to z. U of z conjugate is equal to z, then this is what you will get here. You see, z plus z by 2, 2z by 2 means what? and z minus z conjugate. So z conjugate is z, z minus z is c plus I into v of z plus z conjugate is z, then 2z by 2 is comma. This is our extension. So when putting z conjugate is equal to z in 2, we get language equation 3. Okay. So here this 3 is same as equation 1. You see, you compare with the f of z and equation 1 and equation 3, both are similar. We have x. So here you have z comma 0, we have z comma 3. That means here just what we are doing here in the equation 1, we are replacing x by z and y by 0. We are getting equation 3. Okay. That is, if we replace x by z and y by 3. Thus, to express any function in terms of z, replace x by z and y by, that's all. X by z, y by 0. You will get the function f of z. Very simple. Just replace x by z, y by 0. You will get the f of z, a function. So here you see that what we are doing only without, if you know x or y, anyone, either x or y. X is a u or v. U is the real part, v is the imaginary part. From this one, if you know the real part, you will find the imaginary part. If you know the imaginary part, you will get the real part. But here, without knowing this one, u is given, then automatically, just whatever it may be, the function f of z you are finding very simple. Just replacing x by z and y by 0. You are getting the solution. So we'll do some problems on this one, then we will understand this concept very simple. Now, so how can we find the v? Here, up to this one, the function value f of z we are directly, the analytic function we are finding. But what is the thing we want to find? If the u is given, how can you find the v? How can you find the v? This is the question. By Milnes function. By Milnes function. For this one, without finding the v is over. Up to this one, this is what we want to discuss in Milnes function method. That is over. Now we are using the u, real part of u. By Milnes function method, we are finding the v. Imagine. Now, what we will do? F dash z is equal to dou u by dou x plus I dou v by dou x. Now this is equal to, you see that f dash from this one, from f dash z is equal to dou u by dou x, because y is 0. This is z is x. This z is only contained here the real part. Okay. from this one, what I am finding, dou u by dou x is dash z is equal to, I am taking as dou u by dou x plus I dou u by dou y. Okay, this is equal to dou u by dou x minus I dou u by dou x is equal to, can I write dou u by dou y, dou u by dou y by CR CR by CR. Okay, so let us consider now this dou u by dou x is equal to phi 1 x comma and dou u by dou y is equal to phi 2 x comma. Like this one I am taking. Then f dash z is what? Phi 1 x comma plus minus, here I am substituting I into phi 2 x comma phi. Now to express f dash z completely, this is we are taking as equation 4. F dash z completely in terms of z, where by linear function method we replace x by z and y by linear function. Okay, so then this equation becomes f dash z is equal to phi 1 of z comma 0 minus I into phi 2 comma z comma. So from this f of z is equal to integration of phi 1 z comma 0 minus integration differentiation cancel here. Both sides we are integrating. So then integration differentiation cancel of the f of z is equal to phi 1 z comma 0 minus I into phi 2 z comma, phi 2 z comma. This, this into this plus C1 is fine, where C1 is a complex constant. From this one, we get u of x0. From this, we get u of x0. Okay, so this is the way we find the u of xy if p of xy is given. Similarly, we find the v of xy is given. Yes, yeah. If you know the real part, you will get the imaginary part. So similarly, if v of xy is given, we get v of xy consider v plus iv is This is the way we find it. Okay. So this is the theory of Miller's function method, but in the examination they won't ask the Miller's function method to theory. So just the problems they will ask in the examination. So just find the uh, general analytic function whose real part is given. Otherwise, find the analytic function whose real part is given by Miller's function like this. But this is only for the notes you want to for your reference. Okay, but while doing the problems very simply, you will understand this. Once I will solve the problem, then you will understand the concept well. Okay. Okay. What we discussed today's class: construction of analytic function whose real part is given or whose imaginary part is known. Okay. So here we are discussed two methods. One is the direct method we call, and the direct method what we will do using the total derivative, we are finding the exact differential equation way. From that one we are telling the uh, we are finding the imaginary part while giving the real part. After that, using the imaginary part and the real part, both we are taking the function value u plus id. We are determining. So in the Miller's function method, what we are doing, if suppose the real part is given, so directly we are using x is equal to changing as z and y is equal to 0, we are putting the given function f of z is equal to u of xy plus I into v of xy, and we are finding the f of z value. And after that, uh, from that one, we are taking the differentiation of the function. Again, we are taking the Miller's function expression and we are substituting the values and we are finding f of z value. Right. So this is the way. After that, we are writing the u plus iv is the analytic function. Okay. So this is the way we are finding. So in this class, here only I am stopping. Any doubt, anything you want to ask, please. ఏమైనా అడగాలనుకుంటే చెప్పండి.
No doubt, sir.
Thank you very much. I'm stopping here.
Thank you, sir.
Thank you. Thank you. Thank you.